So the third derivative is 3 by 8 into x raised to minus 5 by 2. So that is equal to 3 upon 8 into x raised to 5 by 2. Now put, instead of x, when we put 4, you will get 3 upon 8 into 4 raised to 5 by 2. Now first of all, 4 raised to 1 by 2, so that is 2, and 2 raised to 5, so that is 32. 32 into 8, you will get 256. So that's why this equal to, you will get 3 upon 256. Okay, now put all these values in the equation, in this formula. You can see this is our formula, right? As I told you, f of x is equal to f of a plus x minus a, f dash a plus 1 upon 2 factorial x minus a square, f double dash a plus 1 upon 3 factorial x minus a cube, f triple dash a. Now we have all these values, f of a, f dash a, f double dash a, f triple dash a, right? And instead of a we have to put 4. So finally we get f of x, that is equal to root x, that is equal to, first of all, f of a is 2. So 2 plus x minus 4, x minus a into f dash a. F dash a is 1 by 4, so 1 by 4 plus 1 upon 2 factorial x minus a square, so x minus 4 square into f double dash a, so that is minus 1 upon 32 plus 1 upon 3 factorial into x minus 4 cube into f triple dash a, so that is, you know that 3 upon 256, so here we get 3 upon 256 and so on. Okay, so now this is our answer. Just we are write down with some simplification. So 2 plus 1 by 4 into x minus 4 plus, now this is 32 into 2, so 64. So that's why we get minus 1 upon 64 into x minus 4 square. Okay, now this is 256, this is 2 into 3, so 3 will be cancel out, right? 3 and 3 will be cancel out, also still also remaining 2, so 2 into 256, that is 512. So you will get 1 upon 512 into x minus 4 cube and so on. So this is our answer, final answer. Here we are expressing this root x, right, in Taylor series where a is equal to 4. So this is our answer, 2 plus 1 by 4 x minus 4 minus 1 upon 64 x minus 4 square plus 1 upon 512 x minus 4 cube and so on. So here is a complete this solution of this example. Next example, question 2c, sketch the curve y is equal to x square modulus of x square minus 1. Now this is quite interesting question, you have to understand each and every term. We want to sketch the curve of this function, that is modulus of x square minus 1. So let's see how we sketch the graph. This is our equation, y is equal to modulus of x square minus 1. Okay, now you can see that this is modulus of x square minus 1, correct? That means what? Just try to understand this term. Y is equal to 1 minus x square if mod x less than 1. That means what? When your x is between minus 1 to 1, y is equal to 1 minus x square. Otherwise, y is equal to x square minus 1. That means if mod x greater than 1. Okay, when mod x greater than 1, that means x less than minus 1 and x greater than 1. Now why this thing happen? Just try to understand. Now when x is between minus 1 to 1, clearly the value of x square is less than 1, right? When x is between minus 1 to 1, the value of x square is less than 1. So in that case, the value of x square minus 1 is less than 0, right? So that's why in that case y is equal to become 1 minus x square, because basically y is modulus of x square minus 1. So when x is between when x square is less than 1, x square minus 1 is less than 0, right? And in that case y become 1 minus x square. Okay, in the reverse part, when mod x is greater than 1, that means when x is less than minus 1 and x is greater than 1. In this two part, when x is less than minus 1 and x is greater than 1, y is equal to x square minus 1, because in that case x square is greater than 1. In both these cases x square is greater than 1. So the value of y is equal to modulus of x square minus 1, that is same as x square minus 1. So here this is our equation 1, call it equation 1, right? This is our equation 1 and call it, this is our equation 2. Now symmetry. First part is symmetry. The graph, you can see the equation 1 and 2 of the curve contain x square, right? That means if we put instead of x, if we put minus x, there is no change in graph, there is no change in the terms of this equation, right? In other words, equation contains even power of x, right? Equation contains even power of x, so that's why the graph of this function is symmetric about y axis, right? Symmetric about y axis. So the equation 1 and 2, so the equation 1 and 2 of the curve even power of x contain even power of x, right? Contain even powers of x. So hence the curve is symmetrical with respect to the y axis. So this is the first part, as we observe that the graph of this function is definitely symmetric about the y axis because of the equation, in both the equation contains even power of x, or if we put instead of x, if we put minus x, there is nothing change in the terms of equation. So that's why the graph of this function is definitely symmetric about the y-axis. So that is the first part we observe about this graph, right? The next part is origin. We want to find out that the graph is passing through the origin or not, that we want to check. Okay, now the graph of this function is passing through the origin or not, but clearly we can see the graph of this function does not passing through the origin, because it contains a constant term, right? It contains a constant term. So clearly the graph of this function does not passing through the origin, does not passing through the 0 0, right? So origin, if we say something about the origin, the equation of the curve contain the equation of the curve contain constant term. So does not pass through the origin. I just write down very shortly that does not pass through the does not pass through the origin, right? So the graph of this function does not pass through the origin. Now also we want to say something about that this graph of this function is in which intersect in which points on x-axis and y-axis. So for that, the points of intersection with axis, the point of intersection with axis, now this is our graph 1, that is y is equal to 1 minus x square, right? This is our graph 2, that is y is equal to x square minus 1. This is our equation 1, this is our equation 2, as I already explained you, when x is between minus 1 to 1 and when x is less than minus 1 and x is greater than 1. Now we want to say something about equation 1, right? For 1, when x is equal to 0, when x is equal to 0, y is equal to 1, when x is 0, right? When x is equal to 0, y is equal to 1. Clear? So the equation 1 of the curve intersect the y-axis 0 1, right? And for 2, when y is equal to 0, for 2, if we take y is equal to 0, x is equal to plus or minus 1. You can see when x is equal to, when y is equal to 0, x square is, this is x square, right? So x square is 1, so x is equal to plus or minus 1, clearly. So hence the equation 2 intersect the x axis minus 1 0 and 1 0, clearly. So the graph of the function is passing through 0 1, minus 1 0 and 1 0. Clear? Now next we want to check that the graph of this function, in which interval the graph of this function is increasing and in which function the graph of this function is decreasing, right? So up to this we already seen that the graph of this function is symmetrical about the y-axis. The graph of this function is does not passing through the origin. Also the graph of this function is intersect the y-axis at 0 1 and intersect the x-axis, right? Intersect the x-axis at point -1 0 and 1 0. Now we want to check that in which interval the graph of this function is increasing and in which interval the graph of this function is decreasing. So for that, let's see the final point, increasing and decreasing nature. Increasing and decreasing nature. Now you can see y is equal to 1 minus x square, y is equal to 1 minus x square, right? And dy by dx, for that when x is between -1 to 1, so dy by dx is minus 2x, dy by dx is minus 2x. So this dy by dx is greater than 0. You can see this dy by dx is greater than 0 in -1 to 0. When x is between -1 to 0, when x is between -1 to 0, you can see that means x, the value of x is negative. So in that case dy by dx is greater than 0 clearly, and dy by dx is less than 0 in 0 to 1 clearly. When dy by dx is less than 0 in x is between 0 to 1, that means x is positive in that case. So the value of dy by dx is